Hey everyone, welcome to our YouTube channel, and in this video we are going to discuss about the phase and the phase difference of an alternating current. In our last video we discussed about the RMS value of the current, the average value of the current. So for example, this was a small derivation that we completed about the average value, and then we also discussed in one of the previous videos about the root mean square value and what is the derivation. So particularly for this particular video we will be discussing about the phase and the phase difference of the concerned channel. So let us say if I draw a signal here like this. So for example, if this is your y-axis and right here we draw an alternating current like this. So basically what happens is that this entire cycle is covered in a particular time frame. So let us say starting from the first and the last position, which is this one over here, the time taken is 1 divided by 50 seconds. So let us assume that this entire cycle is taking this much time to complete. Now what happens is that let us say if this value is O and it is terminating at one particular point E. Now this entire cycle can be broken down into points. So let us say this is point number A, this is point number B, this is point number C, and then we have this middlemost point which is the point number D. So what happens is that this point A here will lie somewhere around on a pi by 4 location. This point B here will lie on a pi by 2 location, followed by point C, which is the pi, and then this point here would be 3 pi by 2, and the last point would be 2 pi. So technically this entire cycle is broken down into different multiples of pi by 2. So what happens is that the fraction of the cycle or the time period which has elapsed since an AC current or voltage last passed a given reference point is called its phase. So for example, if you consider this diagram, the phase can be expressed in any one of the three different ways. So I'll write these points here. So if you want to express a phase, the first kind of method to represent a phase is the angle expressed in radians or degrees. So this technically is the first method of kind of representing a phase. The second is the fraction of a time period. So the second method of representing a phase is the fraction of the time period. And the third one is the time measured in seconds, which kind of is the direct, very direct calculation. So this one is the time measured in seconds. So for example, let us say if I have to express this in the first, this entire cycle, I have to represent the phase using the first method. So as per this first method, what I can say is that the angle expressed in terms of radians or degrees for this particular case is pi divided by 4 or 45 degree. So that means the phase of this cycle is pi by 4. So I'm taking the A as the reference point here. So for example, if I want to calculate the phase at A, this will be pi by 4 or 45 degree. Now if I want to represent this as a fraction of time period, so I'll write this as a fraction of time period. So as far as the fraction of the time period is concerned, so this would be represented by pi by 4 since that time has elapsed, and the total time that it would take is 2 by pi. So when you solve this, what you get is, as the answer is as 1/8 of a cycle. So this is what you get. And the third one is the time measured in seconds. So right here what we have is time measured in seconds. Time measured in seconds, what we have is t divided by 8. Now since the time here that was taken is 1 divided by 50, so this is 1 divided by 50 multiplied by 8, which is 1 divided by 400 seconds, and this is the answer over here. So I hope that this video about the phase and the phase difference was very much helpful to you, and for more such videos don't forget to subscribe to our YouTube channel. Thank you so much for watching. We'll meet soon.